Well, hello, and welcome back to Adrian's Digital Basement 2. This is an Apple II, yes, an Apple II, the original Apple II, and I worked on this on the main channel. The problem was with that video is it got really long because there were issues on the motherboard and problems there that I fixed. So if you haven't watched that video yet, I recommend you watch that first. What I wanted to do in this video is work on this, which was the power supply that came inside this computer. Now, I've been doing all my testing with my own power supply here that I know works. I had serviced this previously, and it was just easier to rule that out as any possible issues. But this thing may be problematic, and at the minimum, I think I gotta get this open and get the refez out of here, and then maybe take a look at the capacitors, change out any that are flaky, which I'm hoping are not gonna be the case, and then maybe this thing is just gonna work. But it may not work as far as I know. So in this video, I wanna test this thing, I want to open it up, I want to do a little bit of service on it, and then I can put this computer back together for the for the main channel video, which I'm going to gloss over the power supply service in that video. I'm just going to fix this computer and then put it back together and be like, hey, look, it's fixed. Go watch another video on the second channel for this if you're interested. So let me clear this stuff off so I can work on this. All right, there is the power supply from this machine. So I'm assuming this is the original power supply from the Apple II. Now I've already gone ahead and removed the screws. They're in this little thing here, which has all the various screws for the machine. Now the funny thing is I had never run into this, and I'm gonna zoom up if I know how to use my camera. Come on, Sony has the slowest zoom. What's really hilarious to me is there are normally 4 screws you take out along the side, well, on each side, so 8 total, and then this bottom cover comes off. Well, this thing's got rivets, one there and one on that side. Now my other power supply, which I just put it somewhere. Okay, I don't know where I put it. The one I was using, it doesn't have rivets here. In fact, it doesn't even have a hole there. These are in the same spot, but those aren't. So I'm gonna have to drill that out, and of course I'm not putting that back in because there's already 8 screws that hold that thing together, and I hate drilling out rivets. I absolutely loathe it. But we gotta get in this power supply, so it's just a fact of life. Ah, yes, look, I just found the other power supply here. So they are lined up end to end, the power connectors right here on both. And look, I mean, it's a slightly different design. This has an extra screw there on the side, but notice just no rivet right there. Pretty rude. Now these here are rivets as well. Well, they are on this one, and this, I don't know what they are here. You don't need to take those off. That's just holding together the main structure of the supply. Really, all you do is you take this bottom part off. Now there are 4 screws that I have in the bottom of this, and that's what holds the power supply onto the bottom of the computer itself. I just stuck them in there for holding them, but on this one, which I took off, these screws that hold it down are also in here. Anyhow, for removing rivets, I think you know the drill, and yeah, pun intended, you just have to use your drill. And I hate doing this. I mean, I'm sure there's really good and quick and easy ways to do it. Maybe a tool that can get this thing out of here. You want a drill bit that is just slightly bigger than the hole in there in the rivet. I mean, this is the best of my limited understanding. And then you just go to town on it. And then eventually when you break through, you're gonna cut through that and it will just sort of fall out. At least I think it will. So why don't we give this a try? I'm just gonna get some eye protection first. Always wanna protect your eyes just in case. Here we are, eye protection. I'll be wearing that even though I've got glasses on. I like to have extra protection. And I'm just gonna flip this over and I'm just gonna start drilling here. Maybe if I had the drill the right way, that would help. Oh, well, that was pretty easy. All right, so what's happened is the rivet is now just spinning around inside of there. All right, so for my tactic, I think what I'm gonna try to do is spread the case a little bit, if I can get this tool in there, to put some pressure on the rivet to maybe stop it from spinning. All right, well, definitely made a hole. Let's go to a bigger size here. Okay, I think that is doing the trick. This rivet is partially out here. I'm just gonna look for a tool to try to grab it. Nope, not quite. But it's coming out there. So I'm gonna drill it out some more. Nope, it is now turning again. Ah, look at that, it worked. I got it out. There is the drill bit. Or not the drill bit, that is the rivet. Nope, it is stuck on there. There it is. So there's one out. So the trick was that I found, and I'm sure people can say better ways to do it, was to put a little pressure on the case and then turn the drill through it. So we're gonna try that again. This one's being a little bit more stubborn. That one is out relatively easily. Please do not take this video as any kind of instruction on how to get these rivets out. There are probably countless better videos out there on the internet showing how to do this. So I went up to a larger drill bit and I removed the head of the rivet. That came off. Now, of course, it marred up the surface here a little bit, but I mean, what are you gonna do? So what I'm gonna try to do is lift up the cover on one side because the rivet is out on that side. There we go. And there it is, popped out, but the rivet is still stuck in there. But now I should just be able to hammer that out pretty easily. There's the inside of that power supply. All right, that is it for the drill. I'm not gonna need this again because we can just use those 8 screws to put that thing back together when we're done. Alrighty, so let's take a look at this power supply. So yes, we definitely have some refuzz down here. There looks like there are 2 of them, which is typical for these things. And working on these is a little bit of a pain. You gotta get this thing off here, this grommet or whatever this thing is called, this nut here. And a viewer just sent me a tool to release this. Is this it? Yes, this is it. This is the tool that the viewer sent in. It is the Pros Kit CP311. And this tool is supposed to allow me to very easily grip this thing, get it out of here. And it does allow me to turn it easily, but I don't remember what I'm supposed to do here. I think just squeezing it and I can pull it through, maybe. I think that did it. There we go. Well, there it is. That's the thing. It came off. It's very much a pain. You can use like anything like to try to grip it, but this tool did help quite a bit. So I appreciate that. I have that now. All right, now we just got to take this board out, and it's got little screws down in here, 4 of them, and then we can kind of lever it out without disconnecting all this stuff. The stuff over here is usually soldered down. I tip that over and we get these screws out. I think there should be 4. There they are. Now the board, oh no, there's 2 more. There's 6. 1 on each side of the transformer as well. There's some kind of glue that's in those screws too, which can make it a little difficult to get the screwdriver down and onto it. So you may have to use something sharp to try to like pick out the gunk, the glue that's in the screws. I don't really get why they did that. I guess to just try to keep them from possibly coming off in the future, or like due to vibration or whatever. All right, there we go. All 6 are out. Tip that stuff out. And there it is. The PCB is now loose. Now you don't need to remove it out of the case entirely. Like, you don't have to disconnect these wires. You can do the work you need to do on the bottom here. And while I'm at it, I can take a look to make sure that there's no bad solder joints, cold solder joints, or even leaky caps. Any of those caps had leaked, it would be very obvious on the bottom of the board. You'd have a lot of kind of brown gunk and corrosion and stuff. These are Nippon Chemicon caps though. I have always found these to be incredibly robust and well made. I mean, think about it. If this is the original power supply from this thing was made in the late 70s. And I am sure when I put this thing back together with new refuzz, it's gonna work well. It's possible that this little cap right here, this one might be a problem, and that's because it's right next to like this power resistor there, so it kind of bakes it. And this cap has to do with the controller that's running this thing, the switch mode power supply controller. It's very primitive design. It has a magnetic, what is this, like an optocoupler, but it's a magnetic version, older, and it's got a couple transistors. So it's a pretty simple design, but this cap does need to work for this whole board to work. So if the thing doesn't turn on at all, I'm just gonna go and swap this particular cap out, which appears to be 220 microfarads at 10 volts. So pretty easy thing to get. The REFAs here, on the other hand, 0.01 microfarad, that X cap, and this one here is 0.1 microfarad. Those two need to come out. Let me find some replacements. All right, just look through my pile of caps here. Here's a 0.01 microfarad, and this one here is a 0.1 microfarad. The problem with these REFA caps is as they age and they get all cracked, they actually start to go short circuit, or like they end up with a resistance like a resistor. And with these types of safety caps, this is like EFI suppression, they actually are usually, or at least one of them is going to be across hot and neutral on this power supply. So what that means is as they short, basically the cap is shorted across your mains. And of course that makes it hot, and then the resistance goes down, so it gets even more of a short circuit, and then it just basically like blows up, and that's when it releases all the horrible stinky smoke and everything into your house. The one that's right here next to the fuse is a 0.01. So what I'm going to do is just heat the pad there and then just slide it out of the board, and then I will use the solder wick to clean the holes. This one is harder to get out because it's next to the fuse. Out, and it's hot. There we go, that came out. That is the 0.01, and look, it's actually not too cracked. It's not REFA brand, I don't recognize the brand. Oh no, it is REFA. There's a crack on it. This would eventually let go. So here we'll just use this solder braid here to clean up these holes, so we can get the new one in nice and easy. There's actually 2 holes for 2 different sizes, which is good because the one I'm putting in is much smaller. Of these 2, it's this one right here, 0.01. Wait, let me just make sure. Was that really the one I just took out? 0.01, yes it was. So what's cool is there are actually 2 footprints there when I cleaned off the solder, and even though this part's a lot smaller than one I took out, it actually goes right in there. I didn't have to do any fancy leg bending. All right, I have my finger on the other one here, so I'm going to do the same technique to get this out. There we go. It's not cracked yet, but it's getting there. The whole thing looks pretty bad. I think moisture goes inside when it cracks like that, and that's why it fails. All right, there we go. Those holes are clean. Now, by the way, if you've tried some of this stuff before and you didn't like it, you might have had really crappy stuff. I buy MG Chemicals Super Wick here. That stuff works really, really well. Like the junk that I had been trying to use in the past, it just did not work well. And I always really struggled with it. So it's really nice to have good quality stuff. All right, there we go. This one's in. It has a different footprint, or has like 2 different footprints available. I used the smaller of the 2, which basically fit right in. And we're just gonna add fresh solder onto this. And there we go, things are soldered very nicely. Let's clip off these legs here. Now, I'm not going to get into the whole should I be recapping this whole thing or not debate, I suppose we're going to call it. Personally, I say no. These caps are incredibly good quality that are on this power supply, and honestly, I've worked on a lot of Apple IIs with this same power supply, and they have all had good caps. I've never needed to replace these caps. Now, I'm not saying that like every single time that's going to be the case, but definitely these caps have not leaked. There's no evidence of any leakage on here, and they're very good quality. If you buy some caps today and you put them on here, you might think you're buying good quality caps, but I'm sorry, stuff is just not made as well anymore when it comes to like, you know, cheap consumer quality stuff that you might get from DigiKey than it was back in the old days. Think about how much these caps cost when this power supply was made. A lot. And new caps, you know, they're next to nothing. And I know you might think cheap insurance, but I've had lots of things from the 2000s where the caps went bad on them and leaked and, you know, stopped working. While this thing is so much older than all of those things, and I bet you this thing is still gonna work. Now, because I don't feel like taking this thing apart again, I am gonna test that little reservoir cap on the controller, or the part of the switch mode power supply thing there that I pointed out earlier, the little cap. So I'm gonna use my ESR meter here, just grabbing some leads. I think, I mean, 99.9%, I am confident that that cap is going to be good. I'm gonna measure it in circuit here. So it's this little capacitor right here, which, let's see where that is hooked up to. It's a little hard to tell. I think it's right here. Let's see what the meter shows. 223 microfarad, and the D value is 0.67. Remember, that's a 200 microfarad cap. If we want to switch this over to look at the ESR, because I know that's how a lot of people like to work. There we go. I've switched this thing into ESR mode. I already forgot which way this was. I think it was this way here. There we go. 222 microfarad. The ESR is 0.49 ohms. There is nothing at all wrong with that capacitor. So there you go. You can see those two new filter caps are on there. So the old REFAs are out. So no more stink bomb coming out of this thing. And you just sort of lift it up into place and slide it down. And then you just gotta align it with those holes. And then let's put these screws back in. And there are little washers, which I'm gonna try to get in place. There we go. I just magnetized my screwdriver. Okay, don't do that, because if you tilt it up, the PCB moves. That seems to hold on to the little washer and the screw well enough. Now, it goes without saying, while you're inside one of these power supplies, inspect, take a look. Look for like burned components, like all these passives here, there's diodes and stuff. Make sure nothing looks like it's, you know, seen better days. And if it does look suspect, test it. You might need to lift one of the sides, one of the legs on there, just to, you know, double check to make sure that it's not, you know, hooked up with something else in parallel. But basically, this power supply is like really simple switch mode power supply. Really nothing fancy going on in this thing. There's no like active power factor correction and stuff like that to go wrong. So if you have an Apple II power supply, there's not a lot that can go wrong with it. It should be something that you can hopefully figure out. Okay, this one has so much glue in it. Struggling there. Let's try magnetizing the screwdriver a little bit more. You know, I don't know if you should like move it back and forth a bunch of times or what the trick is with that thing. Let's see if did that help. Oh yeah, that helped. Now, when it comes to switch mode power supply repair, I'm no expert. I've done a little bit of it before and I've gotten things working. And as I mentioned, it's almost always this little tiny cap here. If the power supply is not starting, or say it takes a long time to start, that cap is the culprit. It seems that smaller caps, when they're next to things that get really hot, that's when they tend to bake and then stop working. And that one was no exception on most power supplies. Now you can have like leaky output caps here. The input filtering caps are really good quality, and these, because they're high voltage, these don't usually leak, but these ones can. I've seen that on newer power supplies, like stuff from the 90s and on, not stuff like this. I don't think I've ever had a leaky cap on one of these like 80s power supplies. Well, there's one thing I want to add is that sometimes the IEC power input, which is this right here, can actually have a REFA inside. Now this one doesn't because it's obviously not big enough, but if you see like a metal can on there, or sometimes it's plastic and it's larger, there's often filtering inside of the plug itself. And Chuck Hutchins, he had a video where he showed that happening, or he replaced those on his pet. And I personally have had a pet let go and let the smoke out. And I mean, you have to think that this is actually right across mains. It's not even like the power switch is not even in play. So it can let go while the thing is turned off. So just keep that in mind if you're working on one of these. Just look for REFAs inside of there, especially if you don't see any on the main board. It could easily be there. Now, it could also be there and on the board, so you have like double REFA. So, you know, just watch out for that. If your power supply is not working otherwise, then my suggestion is, and here we go, I got to try to figure out how to get this thing back together again. If you have a power supply that is not starting, and I'm trying to get this thing back in while I'm talking here, then if that cap is not the problem, then of course the main switching transistor could be shorted. you do need to lift that usually to check it because there's stuff in parallel. Of course, you could have a bad fuse, but if you have a bad fuse, then like what caused the fuse to blow? I'd be highly suspect of other things that are blown on it, like a shorted switching transistor. But you should go ahead and check all the passive components like the resistors, make sure their values look correct, diodes, stuff like that. Check for any shorted diodes on here. These are the output rectifiers, so these are diodes as well. I mean, those could short, I guess, and then I don't know what that would do. Bad things, I guess. Let's see if I can get this back together. Look at that, that was really easy. So yeah, this tool rocks. This tool really, really rocks. So yeah, there we go. So it's all back together. This thing should be good to go. Now, should I be cocky and like put the lid back on? Yeah, sure, let's go ahead and do that. So these are the 8 screws right there. I got them out of the little thingamajiggy. So let's put these in, and of course I'm leaving out that horrible rivet. So if anyone needs to service this thing in the future, it will be very easy for them. Now I think one interesting tidbit about this power supply here is I'm pretty sure that the Apple II was the very first personal computer, so home computer, that came with a switch mode power supply. So 1977, TRS-80 and the PET were both using large transformers with linear voltage regulators, so tons of heat, very inefficient, whatnot. And if you think about all the earlier computers as well, like the S100 bus stuff, the Altair, things like that, giant transformer in there. Same with my Southwest Technical Products PC as well. Just not really efficient. This power supply that I'm pretty sure Apple either designed or I don't know, it's made by Aztec, famous power supply manufacturer. I just don't know how much Apple had to do with it, but I'm assuming this was something that Apple or Steve Jobs probably wanted, just because it was much lighter, more efficient, slicker, cooler, and better. And if you think about it, all modern computers, I mean, pretty much everything these days is using switch mode power supplies if it's hooked up to the mains, unless it's some special test equipment, stuff like that. Okay, so I think this is good to go. I'm gonna grab a motherboard. We're gonna test this thing out. Alrighty, what we have here is an Apple IIe motherboard. Now, this is for a project I'm working on, another project for testing and stuff. So you will see this at a future time. Interesting that the power connector on the IIe is turned 90 degrees from the Apple II and the II Plus, but it is absolutely fully compatible with these power supplies. Obviously, before this computer can possibly work, I need to put a CPU back in it. I do have a ZIF socket that's just sitting in here for testing. So there's a MOS 6502, and yes, that does work in here. You don't need to have some other brand because of course, MOS is the originator. Let's hook up a speaker so we can hear the old beeparoo. And I think I'm ready for testing. We have the multimeter here. I have it clipped on the ground lead. I'm gonna put it right here on this capacitor and let's turn this on. 5.06 volts, everyone. So that, and you heard the beep, that is good sound. Let me poke around and see if I can figure out some of the other voltage rails. I bet you they're up here. All right, we got 5.09, that's good. There it is, 12.0, basically perfect, spot on. This one's not reading anything because I bet you this is one of the negative rails. So we go on that side, there it is, minus 12.0, that's also perfect. And then this one is not reading anything, so that's probably over here as well, minus 5.09. Pretty darn good. All of these rails look excellent. Now I switched the multimeter into AC mode here, so let's go across these caps here. So I'm definitely going to conclude that this power supply is working really well and the ripple is completely acceptable, even with the ancient caps that are in here that I didn't replace. This thing is just a high quality power supply with really good quality caps in there. And by the way, let's just turn it off again and let's like watch how long it takes to turn on before we hear the beep. I mean, the power light comes on right away, so this thing is not slow to start up either. Awesome. So there we have it. That is the testing and service of this power supply from that 1979, I think, or late 78 Apple II. This thing is ready to be screwed back into that base of that computer to serve that computer's motherboard for many years to come. If you enjoyed this video, I'd appreciate a thumbs up, but if you didn't, you know what to do. Huge thanks to my patrons. Their names are scrolling up the side of the screen. I think it'll be on this side over here. If you have suggestions on a good way to get those rivets out of the side of these cases, definitely put that down in the comment section below. It's probably a good tool to do it or something. I just don't do it very often, but I do have to do it periodically, so it is a pain. I want to thank my viewer who sent in these handy tools. That's the first time I've used it in earnest in pulling this thing off here, and that worked a treat, especially now that I know how to use it. So thank you very much for that. And I guess that's going to be that. So, oh yeah, don't forget to watch the video on this machine on the original Apple I if you haven't already. So that's going to be that. Stay healthy, stay safe, and I will see you next time. Bye.